High above the clouds, beyond the blue of the sky, the Earth glows with a light we cannot see. An invisible force surrounds our planet, a vast, shimmering bubble of magnetism, protecting every living thing from the endless violence of space. It is our magnetic shield, the silent guardian that stands between life and oblivion. And within that shield are two vast, swirling rings of radiation, the Van Allen belts, trapped storms of energy that circle our world like luminous halos. They are both beautiful and deadly. A cosmic paradox. The same magnetic field that protects us also cages the very radiation it deflects. This is the story of the Earth's invisible armor, how it was forged in the heart of our planet, how it defends us from the universe, and how it reveals the delicate balance that makes our world habitable. At the center of our planet lies a churning sea of molten metal, mostly iron and nickel, spinning slowly around a solid inner core. This motion generates electric currents, and those currents create something extraordinary, a magnetic field that extends far into space. It's called the geodynamo, and it's the beating heart of Earth's magnetic shield. Lines of magnetic force rise from the South Pole, loop outward into space, and dive back into the North. If we could see them, the planet would appear wrapped in invisible threads of energy, a cosmic cocoon sculpted by magnetism. This field stretches tens of thousands of kilometers into space, forming a vast region known as the magnetosphere. It is here that Earth's protection begins. Like an invisible umbrella, the magnetosphere deflects the charged particles streaming from the sun, the solar wind, a constant gale of protons and electrons rushing outward at hundreds of kilometers per second. Without this defense, the solar wind would strip away our atmosphere, just as it did to Mars long ago. But because of Earth's magnetic field, most of these charged particles are turned aside, swept around the planet like water flowing around a stone in a river. Still, not all of them escape. Some become trapped, spiraling along the magnetic field lines and forming one of the most fascinating structures in all of near-Earth space. The year was 1958. The space age had just begun. Humanity had launched its first satellite, Explorer 1, into orbit, a small, simple craft carrying instruments built by scientist James Van Allen and his team. They expected to measure the intensity of cosmic rays high above Earth's atmosphere. But what they found was something entirely new. The instruments began to register strange bursts of radiation, so intense they were overwhelming the detectors. It wasn't cosmic rays from deep space. It was something much closer and much more powerful. Van Allen realized that Earth's magnetic field was trapping charged particles, creating vast regions of radiation high above the planet. These became known as the Van Allen radiation belts, the first great discovery of the space age, and one of the most important. It was as if the Earth itself wore a glowing crown of energy, invisible to our eyes, but alive with motion. The Van Allen belts are not uniform rings. They are dynamic, ever-changing structures, shaped by the sun's moods and the breath of the solar wind. There are two main belts, sometimes joined by a third temporary one. The inner belt, stretching from about 1,000 to 12,000 kilometers above Earth, is made mostly of high-energy protons. These particles are trapped by the planet's strong magnetic field close to the surface, bouncing back and forth along magnetic lines like beads sliding on strings. Farther out lies the outer belt, extending from roughly 13,000 to 60,000 kilometers. It is composed primarily of energetic electrons, constantly reshaped by solar storms and magnetic waves. When the sun erupts, when coronal mass ejections send bursts of plasma hurtling toward Earth, these belts surge and shimmer, swelling with trapped energy. They can grow stronger, larger, or even split apart. The magnetosphere flexes, breathes, and sometimes trembles under the impact. To a spacecraft passing through, the belts are treacherous, a gauntlet of radiation strong enough to fry electronics and harm unprotected humans. To scientists, they are a living laboratory, a reminder that our planet is not isolated, but constantly in conversation with the sun. Inside the Van Allen belts, charged particles move in complex, elegant patterns, spiraling, bouncing, and drifting along the magnetic field lines. They are trapped, yet restless, guided by invisible hands. Sometimes, electromagnetic waves ripple through the magnetosphere, disturbing these trapped particles and sending some of them hurtling down toward the upper atmosphere. When they collide with atoms of oxygen and nitrogen, they release light, auroras, shimmering curtains of green, pink, and violet that dance across polar skies. The aurora is not just beauty, it's a message. It's the visible signature of Earth's magnetic shield at work, a sign that the planet is alive, protecting itself, absorbing and redirecting the universe's energy in a breathtaking display of light. Each aurora is a reminder that the same radiation that could kill us in deep space is constantly knocking at our door and being turned aside by forces we cannot see. Without the magnetic field and the Van Allen belts, Earth would not be the world we know. The shield protects our atmosphere from erosion by the solar wind. It prevents cosmic radiation from bombarding the surface with deadly intensity. It keeps our climate stable, our air breathable, and our oceans intact. On Mars, where the core has cooled and the magnetic field has faded, we see the alternative, a planet stripped bare by the sun, its sky thin, its surface scorched by radiation. Earth's magnetic field is not perfect. It shifts, wobbles, and even reverses polarity over geological time. But through every upheaval, it has preserved the fragile envelope that makes life possible. The Van Allen belts, though dangerous to spacecraft and satellites, are also part of that defense, a kind of outer moat around the castle of Earth. They trap and hold much of the radiation that might otherwise strike the planet, sacrificing stability for safety. It is a balance, dynamic, delicate, and utterly essential. Our magnetic field is ancient, but not eternal. Scientists studying the motion of the molten core have discovered that the field weakens and strengthens in cycles. Sometimes it even flips, the North Pole becoming south, and vice versa, a process that can take thousands of years. During these reversals, the field's strength can drop significantly, exposing parts of the atmosphere to higher radiation levels. Though life has endured every reversal in Earth's history, such events remind us how dependent we are on this unseen protection. And as we send more satellites and astronauts into orbit and dream of building cities on the Moon and Mars, understanding our planet's magnetic armor has never been more important. It is our model, our blueprint, our reminder of what keeps us safe and what we must learn to recreate beyond home. For if humanity is to survive in the deep and radiant sea of space, we will need to carry a piece of Earth's shield with us. From the moment life first stirred in Earth's oceans, the planet's magnetic field has been there, unseen, unheard, but always present. It is the reason the sky is blue, the reason the air is thick, the reason we can walk the surface without fear of the sun's fury. Above us, the Van Allen belts shimmer invisibly, glowing with energy captured from the stars. They are the boundary between safety and the void, the line that separates the living world from the cold violence beyond. When astronauts leave Earth and look back, they see the planet wrapped in faint blue light, floating in darkness. What they cannot see is the invisible fortress surrounding it, the magnetic cocoon that shields all of life below. It is our armor, our legacy, our most ancient ally. And though we may one day journey far beyond it, the story of Earth's magnetic field will always be part of us. the silent guardian that allowed us to exist at all. Because before there was life, there was protection. And before we could reach for the stars, the Earth itself learned how to stand against them.